Let's talk about calculating the index of hydrogen deficiency, also known as degree of unsaturation for hydrocarbons. Now, the index of hydrogen deficiency, which I'm going to denote, and it's most of the times denoted IHD, tells you it tells you the number of rings, your regular polyhedrons, the number of rings or pi bonds in a molecule. In a molecule, right? Now, when we say pi bonds, we're talking about carbon-carbon double bond and carbon-carbon triple bond, right? So generally, what you're given is a molecular formula, and you are asked to calculate the index of hydrogen deficiency. It's in the name. The molecule that you're given is lacking some hydrogens, right? So that's what you're trying to calculate. Because once you calculate the lacking of hydrogen, you can tell the ring and the pi bonds. We're about to look at some examples. So you need to remember this formula because they're not going to give it to you on an exam. You're going to have to memorize this formula. Your index of hydrogen deficiency is equal to the number of hydrogens in your reference, and I'll tell you what the reference is in a second, minus the number of hydrogens in your unknown. The unknown is the molecule that you're given that you are trying to find what's the index of hydrogen deficiency divided by 2. So you need to remember this formula. Hydrogen in your reference minus the hydrogen in your unknown. Your number of hydrogens in your reference comes from your alkane, right? Remember, your alkane is saturated, right? Your alkane is a saturated hydrocarbon, which means it has the maximum number of hydrogens that a hydrocarbon could possibly hold. So that's why the alkane is used as your reference, right? So it's your reference minus your unknown. Remember, your unknown is lacking some hydrogens. So to get the difference in hydrogen, clearly I'm gonna subtract the one that is lacking from what is loaded with the hydrogen. So this is loaded with the most hydrogens that it could ever have in life. Then I'm going to subtract the number of hydrogens from my unknown, because remember my unknown is lacking, right? So once you subtract, then clearly you get the deficiency, right? The difference will give you the deficiency, okay? Loaded with hydrogen, lacking some. If I subtract it, you're going to get the deficiency, okay? So the number of hydrogens in your reference comes from your alkane, right? And this is what I mean by come from your alkane. Let's look at an example. Let's say you're given C4H8 and you are asked to calculate the index of hydrogen deficiency in C4H8. This is what you do, all right? Your formula, IHD, right? You know that it's equal to the number of hydrogen in your reference. So let's deal with that first, right? Um, let's H reference. I'm just going to rewrite the formula minus the number of hydrogens in my unknown, and we're going to divide that by 2. So to calculate the number of hydrogen in my reference, this is what you do. Go to the unknown, okay? My unknown has 4 carbons. So your reference will be the alkane that has 4 carbons. An alkane with 4 carbons has 10 hydrogen. CnH2n plus 2. 4 times 2 is 8 plus 2 is 10. So the number of hydrogen in my reference is 10. So that's the first thing you do. Find the unknown. How many carbons do I have? 4. Generate the alkane that has 4 carbons. So an alkane with 4 carbons has 10 hydrogens. Then I'm going to subtract the number of hydrogens that is in my unknown. This is the unknown. The number of hydrogen in the unknown is 8, right? So this is 10. 10 minus 8 is 2. Cancel each other out. So 1. Index of hydrogen deficiency in C4H8, IHD for this is equal to 1. What this means is that C4H8 has either one double bond or one ring. remember your index of hydrogen deficiency, right, tells you how many ring, or double bond or triple bond you have in the molecule, or it can be a combination. In this particular C4H8, the answer is one. So you have either one ring or one double bond. Okay. So let's go ahead and draw C4H8 possible structures. So C4H8 can be your square, or it can be butene. That's 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. Yes, so C4H8, and let me count the four carbons. 1, 2, 3, 4. You have two hydrogens here. Let me put them in. So this is also C4H8. So this is something else we also like to say in chemistry, which is true. Remember what we just did was calculate your hydrogen deficiency. So it means that C4H8 lacks hydrogen when compared to the alkane, which is why the alkane is my reference, right? With the same number of carbons. So look at it. C4H8, C4H10. This is your alkane. This is your alkene or your cycloalkane. The thing that lacks hydrogen. So C4H8 lacks two hydrogens when compared to the alkane. The ring in a molecule generally replaces two hydrogens, and it replaces the two hydrogens that is in the alkane with the same number of carbons. So if you have a ring or you have a carbon-carbon double bond, that's why we say you have a hydrogen deficiency, because this double bond, like we like to say, it replaces two hydrogens. The ring replaces two hydrogens when compared to the alkane with the same number of carbons. All right. If let's just say you're like, okay, lady, I don't remember why hydrogen is the reference. That's fine. But you must remember the formula and how to get the number of hydrogen in the reference, and it's easy to get the number of hydrogens in unknown. You're just looking at a formula. Let's do one more example. Let's do C6H10, right? So for C6H10, we have six carbons, right? Six carbons, we have 10 hydrogens, and this is our unknown. So the question is, calculate the index of hydrogen deficiency in C6H10. Okay, so let's try that. First thing, find your unknown. I have six carbons in my unknown. All right, reference, here we go. C6H14, right? It's 6. 6 times 2 is 12 plus 2. That's how I got the 14. So this is 14. Number of hydrogens in my unknown is 10, right? So let me move this out of our way. Put it over here. So this is equal to 4 divided by 2. 27, 1, 24, 2. So we have two index of hydrogen deficiency, right? So it means that this molecule, and I'm looking at C6H10, generally C6H10 or C6 or C5 generally are ring structures, right? I know C6H10 isn't like two fuse ring. It's possibly um one ring and a double bond, or two double bonds in a molecule. You can try different things, right? But the key is the molecular formula must be C6H10. So let's draw a six-membered ring with a double bond and see if that makes sense. And remember, it's 2 degrees of unsaturation. So I have one ring, that's 1 degree, and I have a carbon-carbon double bond, that's number 2. So let's count our hydrogens and see if I have 10. Each one of these carbons from your line angle, I know you're a pro at that, so you know each one of these have 2. So it's 1, 2, or let's go 2, sorry, 2, 4, 6, 8, 9, 10. So this is C6H10, right? What if we drew six carbons What if we drew 6 carbons in a long chain, 4, 5, 6? It has to have 2 double bonds though. It doesn't matter where I put the double bonds. Let's see if this also gives us C6H10. So let's go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is also a possible structure for C6H10. And if you notice, right, it has 2 degrees of unsaturation. It's my 2 double bonds. Those are the 2 degrees of unsaturation. So just remember with index of hydrogen efficiency, you're literally calculating how much hydrogen is lacking in the molecule. And the lack of hydrogen in the molecule shows up as either a ring, a triple bond, or a double bond, right? Sometimes they may ask you to draw structures, sometimes you're not asked to, but you definitely will be asked to calculate the index of hydrogen efficiency. That is a must, so I need you to go ahead and learn that. I also want you to do something for me. I want you to, for C4H8, I want you to draw an alkyne. So that's a carbon-carbon triple bond. So I want you to draw an alkyne, right? 4 carbons, carbon-carbon triple bond, and let me know if you end up with butane, right? And butane is 4 carbons. You have the carbon-carbon triple bond. Let me know if you end up with C4H8. That's how you calculate index of hydrogen deficiency. When you're calculating index of hydrogen deficiency and you have other things added, so if you have a nitrogen, an oxygen, or a phosphorus, I have videos for that. You can check those out.